All right, welcome to a example problem that we're doing in engineering geology. I'm producing these problems for two reasons. One, that you can see that my penmanship is a little bit better than what you see on the board in lecture, and two, is to so we don't take up valuable time in lecture to go over these on the board. I can produce better concepts on more concepts and faster in lecture, and then you can then rewatch these on your online over and over and over again if you need to, back them up forward, slow them down, things like that nature. So hopefully this will be a lot better for you. All right, so here's how we're going to do this. I'm going to go ahead and give you an example problem. We're going to go through the given, the find, the solution, and I'll try to do this very quickly so that way it doesn't waste your time. And also if you need to have more time with it, just simply rewind it. So here we go. For this example problem, we're going to have a given of, this is one we worked in class and didn't have a chance to finish it up. So we're going to have a gamma water, and you pretty much already always know gamma water in any of the problems that you do when it comes to soil mechanics, because you know what the density of water is. In this case, we're also being told we know what the void ratio is, and we also know what the density is. Excuse me, the specific gravity. Sorry about that. And that's just the density of the solid with respect to this equal volume of water in mass. So this is unitless. You just take whatever the density is, divide it by it's a unit density of water, and you get this unitless value called specific gravity. In this example, we are to find your moisture content. And now here's the solution. So any of these, you want to go ahead and create a solution. You always want to create a phase diagram. Okay, you always want a phase diagram. In this case, I also want to further tell you that you are given the fact that this is a saturated soil. So if this is a saturated soil, that means that instead of three phases, where we had air, where we had liquid, and we have solid, since it's a saturated soil, there's no air. So that means we have only two phases in our phase diagram. We have water and we have solids. So what we're going to go ahead and do then is we're going to put on one side we're going to put volume on your phase diagram, and then on the other side we're going to go ahead and put mass. And remember, the density is going to get us between the two. So on this one you have a volume of the voids, which is also equal to the volume of the water. Remember that. On this side you have the mass of the water. You also have the mass of the solids. Then you also have the volume of the solids. So that's what we have so far. So let's continue on and do what we know. First off, we know that we have the volume of the voids. So we know we have E. And E is equal to the volume of the voids over the volume of the solids. Don't mess that up. Okay, volume of the voids over volume of solids. If we go ahead and further assume that the volume of solids is equal to 1, it'd be 1 whatever. Since it's all unitless, it's just 1. So we're being given 1 cubic centimeter, 1 liter, whatever it might be. So if we go ahead and assume that that goes to 1, that's going to give us something fun. That means that the volume of voids is equal to the volume of voids over 1. And we can also further look at this and say, hey, guess what? Volume of voids is also equal to volume of water. So that means that the volume of water is equal to the volume of voids, right? What does the volume of voids equal? E. So we can put that in there. So that is equal to E. Notice what I'm doing here is, if you had, for example, numerical values, go ahead and put them in here too to keep you on track of what we're up to. Now remember, the magical thing, I keep saying magical, but the one that people forget, is the way we get from one side of the phase diagram to the other is the density. Okay, so we need to know the densities to get back from one to the other. In this case, we do know what the density of water is because we were given it. And so now we can get on over here to the volume, to the to the mass of water. So we know that the density of water is equal to what? The mass of water over the what? The volume of water. Since we know that, we then can put in there, if we just divide through, right? So therefore we also know that, well, not equal to, but now we can divide through. And therefore, mass W is equal to volume of water, which is, remember what this is? This is also equal to the volume of the voids, which is also equal to what? E. So it's also equal to E. Pretty cool, huh? So put that up here. So now we know that density of water times E is equal to the mass of water. All right, we're halfway there. Why do I know we're halfway there? Because look what we're asked for. We're asked for W. What is that? W, which is your water content, moisture content, is equal to the mass of, remember? You can pause, right? No, I'm doing it for dramatic effect. It's the mass of the water over your mass of solids. Now remember, this is not mass total. So this is what we're going for. So we have to basically solve this side of the phase diagram. So we've already got one done. Now let's go ahead and get this other one done so we can solve for water content. Now let's go ahead and continue on with that. So now we're taking a look at this. So we're given G sub S, which is your specific gravity. We know that specific gravity is equal to the mass of your solid divided by the volume of the solid times rho W. You know that from the diagrams that we had in the from class. And again, that's just the definition here. So if you wanted to go further, I'm giving you the definition because you already know this. So what you can then do is take, and if you already know that you can divide through, you're going to quickly find out that you realize that when you have the mass of the solids here, that is what we're trying to get to over here. So therefore, your mass of your solids is going to be equal to G sub S, which is your specific gravity, and that's then going to be multiplied by V sub S times the density of water. Now if you remember what we did, V sub S, right, is now, that goes to 0, or to 1 rather, and so therefore your entire equation right here then goes to the specific gravity of solids over the gamma of water. So we're almost there. Okay, we're almost there. So W is equal to the mass of water over the mass of solids, which in this case is equal to your density of water times your void ratio, there it is, divided by your specific gravity times the gamma of water. Not gamma, I'm sorry, the rho water. We'll talk about bulk density in a minute. So those two will cancel, and therefore your water content is equal to your void ratio divided by your specific gravity. And you notice here that your void ratio is sitting right here, and your specific gravity is sitting right here, so you've now solved your solution in terms of what was given. So there is your solution.